Hello, I am Asma, roll number 47. This is assignment 1, programming problem P3, PMI 0 and PPMI transformation. First, I build the sparse word context co-occurrence matrix from the corpus. I use a configurable context window and store only the non-zero co-occurrence counts in sparse form. This is the important because the assignment requires that we do not materialize a dense vocabulary by vocabulary matrix. Next, I calculate a pointwise mutual information or PMI. The formula I use is the natural logarithm of the joint count multiplied by the total count divided by the row count multiplied by the column count. I perform this calculation only for non-zero entries, so I never create the full dense matrix. For zero no co-occurrence counts, the ordinary PMI formula would involve a logarithm of 0. In my sparse implementation, those zero entries are not stored, so they remain 0 in the sparse representation rather than being stored as negative infinity. PPMI means positive PMI. I replace every negative PMI value with a 0 using the formula maximum of PMI and 0. After that, I remove 0 values from the sparse matrix. I report the shape, number of non-zero entries, density and sparsity for the raw PMI 0 and PPMI matrices. I also plot the value distributions using histograms as required in the problem. For the query words, I compare the top 10 contexts using raw co-occurrence counts and PPMI side by side. Raw counts tend to favor very frequent words, while PPMI gives more emphasis to informative association and can reduce the dominance of frequent stop words. Finally, I implement context distribution smoothing. The context probability is raised to the power 0.75 before calculating the smoothed PMI. I compare the resulting top context list with the original PPMI results to see whether smoothing changes the rankings. Therefore, P3 demonstrates the transformation from sparse co-occurrence counts to PMI 0 and PPMI. Reports their sparsity and value distributions. Compare raw and PPMI